Hi everyone. You are welcome to another lecture session on core core mathematics. Yeah, of course, we're still treating indices and logarithm, and today we will be discussing um indice equations associated to indices. Yeah. So let's begin. Hmm, what is that? Um, Solving equations involving indices. So that's what we'll be doing today. Solving equations involving indices. Last time we did not finish the assignment. How many were left?
Said three.
Okay, could you try your hands on them?
Yeah.
Okay, so when we say equations, it's basically any statement that has an equal sign.
Okay.
Now, some equations have variables or unknown quantities as their exponent, and we'll be asked to look for those unknown quantities or variables. So that's what we'll be looking at. And those equations are called exponential equations. Yeah, so exponential equations, they are equations that have unknown quantities or variables as index or power or exponent. And yes, we'll be
I
asked,
see my.
yeah, we'll be asked to solve for the variables or unknown quantities. All right. So normally to solve such equations, we normally use this ideology that if I have m with a power equated to m with another power, okay? As long as the bases are the same, we say that we equate to the powers. So we say x is equal to y. Again, such equations, when you have a term with a power equated to the same term on a different power, we see the bases are the same, so we equate what? The powers. And that's how what we use in solving exponential equations. So I want to confirm if you understand what exponential equations are. These are even examples, right? So it's an equation because there's an equal sign, and it's exponential because it has what? Powers. And of course, powers are what? Variables. Sometimes not necessarily variables. Some can be variables. The other can be a real number or something. But what matters is it's an equation, and you know the numbers involve bears and exponents. That's why we say exponential equations. Is it clear, guys? Is it clear?
Yes, sir.
All right. Now, I've told you that when you see exponential equations, it's one simple ideology we use in solving that. And I said, as long as the bases are the same, you equate what to the power. So that's what we'll be carrying. That's what we'll be using to solve questions like that. And usually, these equations, when you use that ideology with them, it happened that you end up needing ideas in linear, they become linear equations, and you need ideas in linear equations to solve. Okay, you understand it better. Sometimes they end up becoming quadratic, and you need ideas in quadratic equations in order to solve. So it will, even though I've not done equations with you, this aspect will teach you how we solve linear equations, how we solve quadratic equations, and some also turn up to be simultaneous equation or simultaneous equation, however it's called, simultaneous equations. So let's see, we'll start with some examples that will make us understand things more better. So to begin with, let's look at our first illustrative example. So assuming you have three exponents, x to be equal to 9, and you're asked to find the value of x, how do we go about that? So let me know when you're done with the right, and then we talk about it.
Please continue.
Okay, so um so I just told you that exponential equations, the only way to solve that is by um the only way to solve that is by using the idea that trying to see if you can use this analogy, bases being the same, you equating the powers. Okay. So to be able to do this, the question we have to ask ourselves is that can we express this on the same base? If you cannot express it on the same base, then it cannot be solved. You leave it like that. But most cases, it's once you are given a question like this, meaning it can be expressed on the same base. Do you understand? So the question is 3 exponents x is equal to 9. The base is what? Well,
3.
the base is 3.
Yeah.
So, and it's the least. This is big. So ask yourself, can you express 9 with a base of 3? Considering index, can you write 9 with a base of 3 raised to an index? What matters to us is the base.
Yeah.
Yes. So it will become what?
3 exponent 2.
Yeah, 3 exponent 2 will give you 9. So now you see the bases are the same. So if that is so, then you see since the bases are the same, x is equal to 2. That's all. You equate to the power, so the top x equals 2. Yeah, that's all. All right. Let me know when you are done writing. I'll give you another one. We look at that. And if you have any question to you can feel free to ask me.
Please, you can continue.
Okay. So the others, you are spectators, eh? I will remove you all from the meeting. You wouldn't contribute. Okay. If 3 exponent x minus x, sorry, is it divided by 1? I guess. Let me check. Is it minus or divided by 1? I think it's minus, guys. 3 exponent x minus 1 equals 9 exponent 4. Find the value of x. So you see, it's an exponential equation. right? Because it's exponential because every term here tend to have a power. 3 has a power, right? X minus 1. 9 also has a power, so it's exponential. Then equation because it has an equal sign. Okay. All right. So now, what do we do? Yeah, solution. Yeah, so once it's an exponential equation, there is only one way out. That's checking to see if you can put them on the same base, then you can easily equate the powers, all right, to arrive at an answer. If you can't do it, don't force it. So here, um, 3 exponent x exponent x is 3 exponent x minus 1 equals 9 exponent 4. Talk to me. What can we do here? Can we express it on the same base?
Yes, sir.
Yeah. So help me do that.
So 3 exponent x minus 1
Mhm.
is equal to 3 exponent 2
Yeah.
and into brackets 4.
Okay.
Yeah.
So that is it. 3 exponent 2 to represent 9. Okay. Then already the 4 was there, so you put it in bracket. Now, since the bases are the same, we have x minus 1 equals 2 times 4.
Divided by 4.
Yeah. So x minus 1 equals,
8.
so we have x minus, so yeah, now guys, this is called a linear equation. You see, I told you that when you apply this concept, you are most likely going to land on linear equation, quadratic equation, or simultaneous equation. Can someone check the right pronunciation for us? Is it simultaneous equation?
So some people pronounce it simultaneous, some people pronounce it
Yeah,
simultaneous.
but
It's,
can
it is
can
simultaneous.
yeah, can you use your Google to check the pronunciation for us?
It is
Okay.
simultaneous.
I wish to hear the sound myself. I'm coming. Okay, so demons. Let's learn it once and for all. Simultaneous.
Simultaneous.
Mhm. Okay, simultaneous. So if I'm wrong, you correct me. All right. So
Okay,
yeah,
sir.
yeah. So uh-huh. So guys, this you see when we decided to use this concept, it brought us to this. Okay, this is a linear equation, and I'm going to explain it to you. How does it become an equation? Because of the equal sign. Okay. How is it linear? It's linear when all the numbers or variables involved has a power of 1. You know any number standing on its own has a power of 1, right? So x is power 1, 1 is power 1, 8 is power 1. Do you agree with me?
Yes, sir.
So that makes it linear. Okay. How do you solve linear equations? To solve linear equations, um, yeah, to solve linear equations, just group the variables to one side. So here it's just x involved. So I'll just put x at one side. So group the variables at one side, then equals 8, right? Now,
Yeah.
one push it to the other side. Not forgetting that if it's minus, when it crosses the equal sign, it's what?
Plus
Yeah, so it will be a plus 1. So in the end, x is equal to 9.
9.
All right. So that is it. Now, when it appears as a quadratic equation, too, I'll teach you how we solve that. Any question? Okay, example 3 is for you. Finish writing. Let me,
Okay, sir.
then I'll give you the third example. Cecilia, how is work?
The work is fine.
Okay. Patience, how is home? Are you working?
Sir, please, yes.
You working?
Yes, sir.
Or work? Do you mind sharing? It's okay if you don't.
Sir,
It's
please,
okay
sir.
if you don't want to. Okay. Do you want to
Okay.
share?
Yes, sir. Please, is teaching.
Oh, nice. Um, a high school student or junior level or crèche, which is which?
Sir, is primary.
Primary.
Yes, sir.
Primary is nice. What level? Primary one?
Sir, primary two.
Primary two. Okay. Are they not annoying?
Oh, sir, don't worry. I know how to handle them.
Okay.
Yeah.
Venice, how is it going? Are you also working? Mm. Venice, Venice. She's inactive. Rahel, Rahel Afari. I'm trying to picture the face. Oh yeah, Rahel. Is it Afari?
Sir,
I hope I'm correct.
yes, sir.
Let me check my.
Yes, please.
Oh yeah, yeah. How is it going? Work.
Sir,
Mhm.
everything is good.
You working?
Yes, sir.
Okay, okay. Mm. Guys, I'm waiting. Are you done?
Yes, sir.
All
Yes,
right.
please.
Look at that. Number three. So this one you do that yourself. Andrews, are you still doing your job?
Yes, sir.
Okay. Um, oh man. Yeah, so just tell me what it is. For this question, if you want, I don't think you can re-express 64 on a base of 16. I don't think so. If it works, fine. But if it's not working, then you have to think of a number you can use to express each of them. So, for instance, if it's three, ask yourself, can you write 16 on an exponent of 3 and write 64 on an exponent of 3 with an exponent of 3? Or if it is 5, can I write 16 on a base of what? 5 with an index, while I can also put 64 on the same base of 5 with an index. You descend on that and I may make some conclusion. All right. Yeah, the answer is right. So how did you solve that? Tell me.
So I look for a base that could
Work for all.
go into that could go into 64 and then 16 at the same time.
So what number is that?
4.
Okay. So for 64, it becomes what?
4 exponent 3
Mm-hmm.
x
Okay.
equals to 4 exponent 2.
Okay. Mm-hmm. So,
Since the bases are the same,
okay. Those are bases are the same. Mm-hmm.
3x is equal to 2.
All right.
And you divide through, we want to make x the subject, so you divide through by 3.
By the way, I was going to tell you guys, when you get to this stage, repeat the step, okay, before
Okay,
you
sir.
divide, yeah. So
Okay, so
x will be equal to 2 on 3.
divide 3. Okay.
Yeah, that's correct. There are more.
And you said we should repeat the step.
Yeah,
Where exactly?
when you get here, usually you will just divide by 3 right there. Don't do that.
Yeah.
Repeat the step.
Oh, okay.
Yeah. In the marking scheme, they take that as omission of step and some marks as subtracting for comma. In fact, every any other mark. All right, I have another question for you. So all these are linear. That's how come you can just divide through. Some cases you have to group them. Yeah. How about this? Example 4. If I 3 what? 3x squared minus 1 is equal to 9 exponent 4. Solve the I first. I
Okay.
3 root x equals 9. Find the value of x. Everyone solve the I first. Don't attempt the I. Wait for everybody to be on the same page. So yeah, over to you. And of course, it separates itself from this. All right, solution. That's my calculator closer to me. 1 second. I like to, yeah, I found that. Yeah, I like to show something on it to you. So, let's start. So we have 3x, sorry, the x is an index. So 3x squared minus 1 equals 9 exponent 4. Do not panic about what is at the top. It will make sense soon. Okay. Concentrate on the bases 3 and 9. Let's concentrate on that. So what did you do over there?
So you find the same base.
Okay. So the 9, what happened?
3 exponent 2
All right.
Exponent.
Yeah. So now the b's are the same. So at least it does away with that and we can concentrate on the rest. So since the bases are the same, x squared minus 1 equals 2 times 4. So now it makes sense. So you have what? X squared.
X
Mm-hmm.
minus 1 is equal
Then
to
minus
8.
1.
Yeah, 1 second. One second. Yeah. So x squared minus 1. Go on.
It's equal to 8.
Equals to 8.
Okay. Now, here I want you to be very careful. So it's an equation, right?
Yeah.
Yeah.
But it has numbers and variables. And the highest
Yeah.
power on the variables, the highest power you see, when I say highest power, each number or term might show an exponent. Now, the highest exponent you can visibly find is is what determines the name of the equation. So here, the highest power we can spot is what? 2, right?
2.
Yeah.
Yeah.
Yeah, so the equation, so any equation with a degree of 2, the highest power being 2, is a quadratic what equation. Now, every quadratic equation has two answers. Take note of that. It has two. It's mandatory. Every quadratic equation has two answers. Yeah. It has a positive answer and a negative answer. You might not see it properly from here, but as we progress, you see what that quadratic equations, and you see that all the time the answer is either positive or negative. Okay, so every quadratic equation has two answers. The answers, we have a special name we give to them. We call them roots. So if you see any word like this going forward, find the root of a quadratic equation. It means find the answers of a quadratic equation. Do you understand? Uh-huh.
Okay, sir.
So now we have x squared, right? So here you do grouping because the variable is just one. So x squared will be here, then it will be 8 what? Plus
Plus 1.
1. Yeah. We have a special way of solving quadratic equation, but here usually we use it on once you see two variables, x squared minus 2x. You see the variables has appeared what twice. So yeah, the variables have appeared twice. So we use the methodology to solve quadratic equations properly. But here it's one, so I can simply let it stamp somewhere, then we deal with it. So we'll not go in depth. So we have x squared equals what? 9.
9.
Then now, you know, you are looking for x, you repeat the step. You are looking for x. It's squared, so take the square root. Okay, so normally powers have relationship with root power. They have relationship with roots. So square has a relationship with square root. Cube, any cubic power has a relationship with our cube root. Same applies to anything. 25 has a relationship with what? 20 feet what root. In a sense that if you see 25, like a power of 25, you can erase it by introducing a 20 feet what root. Yeah, so I introduce square root so that it cancels off, right? And math,
Yeah.
whatever you do on the left hand side, you do the same thing here.
Yeah.
Now, x ordinarily should be equal to 3, but
Yeah.
I said quadratic equations must give two answers, a positive answer and a negative
And negative
answer.
answer.
So
Okay.
it will be plus, the answer is plus 3 or what? Minus 3, right? Or some books will simply write 3. They write plus or minus like this. Plus,
Okay.
minus, plus or minus 3. It means the same thing. Okay. Now, I want to show you from your calculator. Do we all have the scientific calculator?
Yes, sir.
All right. So tap on mode. Let me see if I can illustrate that. Yeah. Wait, hold on. Let me pin myself on your screen. 1 second. Yeah. So you tap on mode. Mode is here. This mode on top. Then you tap on, you see equations. It's number 5. Yeah. Equations is, it's the number written close to it is 5. When you tap on equations, there are different kinds of equations. And all the equations has a variable, right? Now, they have a variety of variables. Look for that equation whose highest variable, sorry, whose highest power is what? 2. That's a quadratic equation, and it's number what? 3. Are you guys following?
Yes, sir.
Yes,
Now,
sir.
now, um, let's go back. Press mode 5 equation. All right, don't press 3 yet. I want you to observe something. Mode 5, don't press 3 yet. Now study the quadratic equation number 3. You see that it's ax squared, then bx, then c equals 0. A represents the number that is attached to x squared. B represent the number that is attached to x. C represent constant, like that number without a variable. That's all. So knowing that, now check the screen. Knowing that, now check the screen from here. Yeah, check the screen from here. Okay, can you see? So at this point, it was x squared, right? Minus 1 equals what? 8. You can rearrange it like that. So it will be x squared, right? Minus 1. Bring the 8 there. So that will be minus what? 8 equals 0. X squared is x squared minus what? 8 minus 1 minus 8 is what? Minus 9 equals 0. Now come and put it on the calculator. Now press 3. Press 3. If you press 3, you see the first box stand for A. A represent that number that is attached to x squared. And here x squared, there is no number attached to it, so it's assumed as what? 1, right? So you press 1, then you press equal to. Press 1, then press equal to. It will jump to the next box. B, if you take yourself back, B was a number attached to x without a square, right? And here, do you see any number x here? Do you see any number with an x?
No.
No. Thanks for being honest. So you no means 0. So press 0 and press equal to. All right. Then now, C is a number without any variable, of course. What number is here?
9 minus 9.
Minus 9. So you press minus 9, then you press what? Equal to. Now press equal to. The answer is what? 3. But I told you quadratic equations give 2 answers. So you should expect another answer. Press equal to again. What do you get? I'm sure you didn't do it. It's 3 and minus 3. Did you do
There's
that?
3 minus 3.
Yeah. If you are lost, you can let us know. If you are lost, you can let us know. Yeah, so the calculator gave you that. Okay. Let's move on. Yeah, check the second question. The second question is, have you seen it? I. Oops. 3 root x equals 9. 3 exponent root x equals 9, right? So I. 3 exponent root x equals 9. Show me. How did you go by that?
So 3 exponent x is equal to 3 exponent 2.
Is it x or root x?
Root x, sorry.
Okay. Since the bases are the same.
And the same.
Oh, but this should be simpler. Okay. What happens?
Root x is equal to 2.
Okay. Oh. Now, if
Mm.
oh really? Is that the case? Hold on, let me check if we've written the right question before I even waste my time. Why is
Okay.
it? Where did I take this from? 1 second. Where did I take this from? I want to be sure we've written the right question. Then we can what's that? Where's the question? 3 root x equals 9. Yeah, it's correct. So let's see. Yeah. So we are looking for x, right? So
Yes.
let's see. Now, if x was raised to an index of 2, oh, you would have said to do away with the index. There is a relationship between index and root of numbers, right? We said that. So if it
Yeah.
is root, use the power to cancel it off. Do you get the analogy?
Yes.
Mm-hmm.
So the two will cancel.
Yeah. So I'll just, since it's root and I want to do away with the root, raise it to a power of
So
2, then
two.
away.
Yeah.
Yeah.
Okay.
And math, whatever you do on the left hand side, you have to do the same thing here,
So
right?
x is 4.
Yeah. So x is equal to 4. Yeah. And what
All
were you
right.
guys getting? How did you magically form them? Wow. So yeah, that is it. I hope you understand.
Plus
Let's
2.
see. 1 second. Yeah, I have another set of questions. Yeah, example 5. So you've learned how to solve quadratic equations, but not in depth like that. We didn't even look
Yeah.
at the steps involved in solving quadratic equation. Hopefully it brings itself well, then I show you how we deal with that. But I show you how you can use a calculator to get an answer. Find the truth set of the equation. Equation is 8 exponent x minus 2 equals 2 exponent x minus 8, or x is a real number. Yeah. Okay. So yeah, over to you guys. Tell me the process. Tell me the
8,
process.
8 exponent x minus 2 equals to 2 exponent x minus 8.
Go on.
We find the same base.
Okay, so what's that?
So that's 2.
I'm coming, hold on. Okay, 2 what?
Yeah. So 2 exponent 3
Okay.
into brackets x
Good,
minus
good,
2.
good. Without the brackets, you mess up everything.
Yeah. Equals to 2 exponent x minus 8.
Okay.
Since
One
the bases are the same.
1 second. Yeah. Mm-hmm.
3 into brackets x minus 2
Mm-hmm.
equals to x minus 8.
Okay.
So we have 3x minus 6
Mm-hmm.
equals to 8x minus 8.
Okay.
You group like terms.
Yeah, so you have one.
3x minus x
Mm-hmm.
equals to minus 8 plus 6.
Hold
So
on.
okay. We have 2x
Mm-hmm.
equals to minus 2.
2x equals minus 2.
Yeah,
Yeah.
divide 3 by 2.
Okay. That was smooth. X equals what?
-1.
-1. Be ready to learn something here. The question says find the truth set. It's not there for fancy purposes. So to
Okay.
find the truth set, there is a way of re-expressing the answer. So you write truth set is equal to, you open parentheses, x is such that x, that's how we write it, depending on the variable. If it's a equals that, you see a is such that, okay? So x is
Okay,
such
sir.
that x is equal to -1. That's all. Then you close the curly bracket. The curly bracket is not this way. All right. So it's usually, I remember back in junior high school, we're taught that is, I think, what you do an S or something, then two, something like that. Did I?
Oh, okay.
Wow, something like that. You do an S, then you try to do a two also. Figure it out, guys. That's how you get it. Yeah. S and yeah. S then two. Yeah. So that's how we write truth set. X is such that x is equal to -1. Yeah, that's it. Yeah. Let me know when you are there.
Sir, please, you are there.
Okay, another question. After this, the next thing we'll be doing is logarithm.
Okay, sir.
Yeah. But I don't think we'll be able to start today because the variety of questions and the kind of question I want you guys to familiarize yourself with. I don't think we've gotten there yet. Now let's see. Example 6. If equals 1/8, no, 1/81, find x. Yeah, let me swap my charger. Yeah, tell me, how you did that. Hold on, 3 exponent x minus 2, x minus 2 equals 1/81. Yep.
Yeah.
Yes.
So
And then
3
one.
is
Okay,
Okay.
carry on.
3 exponents x minus 2 equals to 1/3 exponents 4.
Okay. Go on.
So for this, I try to use the reciprocal of
Of
it.
course.
Yes.
Patience, you didn't do this. Go on.
So 3 exponents x minus 2
Mm-hmm.
equals to 3 exponents -4.
All right.
Yeah. Since the bases are the same.
Yeah, since the bases are the same.
X minus 2 equals to,
Hold on.
okay, sir,
Since the bases are the same, x minus 2 equals what?
-4.
So x is equal to what?
If okay, it's
Minus
so x
2,
equals to -4 plus 2.
which is, yeah. So this is it. I have more for you. Unfortunately, we can't really continue to logarithm until we've cleared all kinds of questions. Yeah, this is another one. What's that? Example 7. Find the value of x if 2 exponents 3x minus 1 equals 128 root 5. No, root 2. I'll be waiting. Solving side, solving side by side sometimes confuses you, the individual. You end up making mistakes. Are you guys ready? Okay, so this is 2 exponents. 1 second. So it's 2 exponents 3x minus 1 equals 128 times root 2. Yeah, that's what 128 root 2 means. 2
Okay.
exponent 3x minus 1. I think that, why don't we look for, okay,
2
well,
root
there are
7.
many ways to
Yeah,
do
2
this.
root
So
7.
come again.
2 root
2 root
7.
7.
Okay, fine. You guys call me off guard. So times root 2, you already know is 2 exponent half. Have you forgotten?
Yes. Yes.
So 2 exponent 3x minus 1 equals. The bases are the same. Pick one. They are multiplying. Add the power 7 plus half. 3x minus 1 equals 2. This you can punch it on a calculator. What is that?
Please, I want to ask a question.
Yeah, go on.
Please, how did you get the half?
Magically. Yeah, you did not join my meeting the other time. How will you know? Well, I said there's a relationship between root of numbers and it's one rule we learned in indices. There's a relationship between root of numbers and fractional index. So the whole concept is that when you have you pay attention. When you have a number raised to a number raised to an index of half, you can re-express it as root of the number. Now, the name of the root comes from the denominator. So it will be second root, which we don't even like writing. So it's equal to root of that number raised to what? A power of 1. The power comes from the numerator of the fraction. Yeah, you'll be confused, I know. Let me give you another example. I have b exponent 1 over 3. I can re-express this as root of what b. Oh, the name of the root will come from the denominator, so it's cube root. Then that b, don't leave it alone. It has a power of what? 1. The 1 comes from the
1.
numerator. Yeah, I will do you a favor by implementing one more example. So we can have c exponent 4 over 5. Yeah, it has a connection with root of numbers, so it will be root c. The name of the root will come from the denominator, so it will be fifth root of what? C. Then the power is what? 4. It comes from the numerator. So when I see stuff like this, when you get this thing, when I see root of a, I can easily take it back that you initially were a exponent a certain fraction, which I'm here to identify what fraction it is. You were a exponent a fractional index, and the name, how we got the name of your root came from the denominator, right? And the denominator, the root here is 2. Normally, square roots, we don't like bringing the 2. So the square root over 2. Okay. Yeah. Is the denominator that gave us the name of the root. Then the a is standing alone, meaning it has an index of 1, right? So meaning it's 1 over 2. So it's a rule we learned in indices. It's uploaded. So knowing having root 2, I can rewrite it as what? 2 exponent what? Half. Do you get it?
Yes, sir.
Okay. So Now 2 exponent 7 plus 1 over 2. 7 plus 1 over 2 is what? Is it 15 over 2?
15 over 2.
All right. Now, since the bases are the same, is this girl okay, patient? Okay.
Sir, please, I'm okay.
Okay, so 3x minus 1 equals 15 over 2. Then you solve this algebraically, which I think it shouldn't be an issue. It's a linear equation, so you stand here, equal sign come, 15 over 2. Push the 1 across, it will be plus 1. I'll have 3x. You can use your calculator. What are you getting? 17 over 2. I don't know if I'm correct. Yeah.
Yeah, 17 over 2.
Then now at this point, what do you do? At this point, I think
Cross
this is
multiply.
believed to be over 1 cross multiply. So that will be, or you can apply
3.
different approach. Yeah. So 3x times 2 is what? 6x equals what? 17. 6x equals what? 17, right? You
Yeah.
divide by 6, you divide by 6. My back really hurts. X equals what? 17. I think 17 over 6 cannot be reduced further, right? We leave it at that. Yeah.
Mm-hmm.
X equals 17 over 6. I believe there's a final answer, nothing else. Let me go and check. This should be the answer, though. Yeah, that's correct. Any question? Any question?
No, sir.
Are you guys tired?
Sir, no. Sir, question.
Go ahead.
Said the root 2.
No, sir.
Mm-hmm.
Said the root 2.
Mm-hmm.
When you're explaining, I'm confused. So
Oh.
let's use a root of another number when you're trying to explain what Patience was
Mm.
asking.
Okay, so
Yes.
she lacks the foundation, so that's why I had to go the long way. I was just looking for a simple way for her. She lacks the foundation. So
Okay.
everything I taught you still holds. So the whole point is that when you have a number, the point is that when you have a number raised to, you are wondering how I ended up getting a exponent half. And I'm like, usually when you have a number raised to a fractional index, there is a connection between numbers with fractional powers and root of numbers. There is a connection. So any number with raised to a fractional index is equal to the root of that number. Okay. The name of the root is gotten from the denominator, so n, right? Then that number don't
Yeah.
stand alone. It has a power. The power is what? M. It comes from the
Um.
numerator. That's all. That is all.
Okay.
And what that means is that if I give you this two, you can retranslate it back to this. You get it? So now let's see.
Yeah.
I gave you root what? E. Was it? No, I
Yeah.
think it was root 2 or something. It's
Yes.
hard. So root 2, I'm trying to say that, oh, if it's root 2, you know that root of numbers have a connection or relationship with numbers with fractional powers. Do you
Okay.
understand? So root 2, right? I know originally it was 2 with a fractional power, box over box. Now we have
Yeah.
to identify what is at the top and what is at the down. And
Down.
if you
Okay.
and if you refer from here, usually the name of the root comes from the denominator of the fraction here. Okay, so now this root is here, right? A square root. How do you end up getting, square root can be, it's mostly written without the two, right? How did you
Okay.
land at square root? It is because that fraction, the denominator was 2. The denominator was 2. That's how come you quickly move by saying that this is equal to root of what? 2. Assuming the denominator was 3, as in 2 exponent something over 3, You would have done cube root of what? 2. Then you look for the numerator. Do you get it? Do you get it?
Yes,
Yes,
sir.
sir.
Yeah. So we are not done. So the whole point was root 2, right? And we said, oh, then it's actually 2 index a fraction. Now the name of the fraction, we're looking for that. Now the name of the root, which is 2, will represent the denominator. Then now, what will be at the numerator is usually the power of 2. 2 is standing alone. Oh, no power. Any number standing on its own has a power of 1. So the
1.
numerator is 1. So 1 over 2. So root 2 is the same as 2 exponent 1 over 2. Was it root 2 what? Or let me check the question.
So it's root 2.
Yeah. So that is it. And this thing tomorrow you forget. That is
So
why
yes, that's what I've asked you. So maybe let's use the root of another number so that we don't forget.
yeah, so even
So
after
probably
doing that,
root
you
3
still
or
forget.
root 5.
Even after that, you still forget. So it's important you know, you you take your book and solve more examples. I mean, I'm telling you, forget this tomorrow. Is root 3 okay? Is
So
root 3
yes,
okay?
let's use root 3.
Yeah, of
Yes, sir.
course.
Okay.
So if root 3 is fine, to rewrite this, you just know that root of numbers have a relationship with that number raised to a fractional index. Because normally it will be 3, the number raised to a fractional index that give the root of that, right? So now let's
Okay.
see. So I've written 3 with a fractional index. Now the name of the base comes from the name of the root. It's square root, right?
Square root.
So
Okay.
the base will be 2. Then the numerator is usually the power of the number,
Okay.
which is 1. It's
1.
standing on its own, it means it's 1. So 1. Oh, let's do this. Fourth root of 9. No, not let's say 9 to 6. It may not be proper, but we just learn it. How do you re-express this? You know that 9 to 6
9 to
was
6.
raised
Yes.
to what? A fractional what? Index.
Yes.
It's any number raised to a fractional index is what give the root stuff. Now, the denominator will be the name of the root. So what was that?
4.
Yeah, it's fourth root, so 4. Then the numerator will be the power of 9 to 6. It
1.
has no power, so it's assuming it's 1. That's
Yeah.
all.
Oh, okay. So understood.
Yeah. Believe me or not, you'll forget tomorrow. So go and practice more examples. If you just look at the notes, you don't practice, we're not getting anywhere. And that's why I don't enjoy to teach when I start a meeting and people that didn't join previous session join now for that particular day's class. Because I wonder what foundational knowledge you coming with. All right. Um, look, I have other examples. This is for you. So this example 8. One second. Let's solve for x in the following equations. So we have 3 exponent 2x 3 exponent 2x equals 1 over 81. Now this is easy.
So should we solve or we should wait for the questions?
Yeah, this one is your assignment. Don't solve the I. If I write anything and it looks easy, it's assignment. 3x and x plus 1 equals 81. This is also easy. It's an assignment. So write it. I. No one should tell me answer for I or I. It's an assignment. 3 exponent x plus 5 equals 9 exponent 4. This is also an assignment. It's easy. Even. 3 exponent 2x minus 1 equals 1 over 27. It's also an assignment. It's easy. Vin.
Sir,
Yes.
please, the is it's not clear. Please, please let me
3
look at that.
exponent x plus 5.
No. Okay, I think that'll be for the I.
Yeah.
3 exponent x plus.
This is I.
I.
Okay. Okay, so please, can you please
The
read out the
I
I?
is 3 exponent x plus 1.
Okay, thank you.
What's that even? Yeah, Vin. I'm on Vin. Okay. 1 over 3, 27 what? X. Yeah. Now the Vin, you do that, even though it looks easy.
So we should do it right now.
Yeah, the Vin, you do it right now. We still
Okay.
have some time so that we can go to the hey, the questions are much. Okay, the other questions we 2 questions, yeah, that involves simultaneous equations we can try. Walk us through the process.
Okay, sir. So
Mm-hmm.
9 exponent x
Mm-hmm.
equals to 1 over 3
Mm-hmm.
and to bracket 27 exponent x.
All right.
So I try to find the same base, which is 3.
Mm-hmm.
So we have 3 exponent 2
Mm-hmm.
into bracket x
Mm-hmm.
equals 1 over 3.
Yeah.
And then the 27 is expressed as 3 exponent 3 x into
Bracket
bracket.
or one.
Yeah. Yeah, into bracket.
That.
Yes, please.
Okay, go on.
So 3 exponent 2x
Mm-hmm.
equals to, I will express the 1 over 3 as 3 exponent negative 1.
Sure.
And then the bracket indicates that they are multiplying. So
Yeah.
times 3 exponent 3x.
Yeah. Mm-hmm.
Since the bases are the same,
Mm-hmm.
2x equals to
Really. You let me see where you head into. 2x equals 1.
2x equals to negative 1
Mm-hmm.
plus 3x.
Okay. But you know what? It's better to do this. It's better to, I don't know who will be marking, but oh, sorry. It's better to solve that portion first. There should be a
Okay.
reason why you adding them.
Okay.
So here it will be 3x with a negative 1 plus or 3x. Yeah,
3x.
before you can now go on, since
Okay.
yeah, the bases are the same. Yeah, since the bases are the same. So you have 2x is equal to what? Minus 1 plus what? 3.
Plus 3x. Yeah.
Now you group them, right? Go on. Mm-hmm.
So 2x minus 3x
Mm-hmm.
equals to minus 1.
Equals minus 1. You're right.
So
Mhm.
2x minus 3x equals to minus x
Minus x.
equals to minus 1.
Okay.
Yeah. So next step, minus x equals to minus 1. You divide through
Exactly.
by 1.
You divide through by what?
Negative 1.
-1. Yeah.
Yes, please.
So this cancels that. X
So
equals
x
1.
equals to 1.
Oh, yeah, you're right. I hope it didn't ask you to leave your answer in a true set form. No.
No, sir.
So, guys, so this is the final answer. We'll allow you to raise any question or concern you may have. All right. So I'll end the session now, and I will give room for questions, both related and unrelated.